Okay, our topic for today, for week 14, it's all about surface preparation techniques and painting. Why do we have to paint? Why do we have to attend the maintenance for the corrosion? It's because of our ship is made of steel and it has to be seaworthy or presentable. With that, we have to attend the maintenance for the uh, surface preparation and painting. With most ships being made mainly of steel, corrosion is an unavoidable fact of life as the iron is in the steel reacts with atmospheric oxygen. In a natural cycle that would, if not kept, okay, at bay, return the steel to iron oxide in a relatively short space of time. Then corrosion happens. So what corrosion needs or rust needs are the following: the anode, the cathode, and the electrolyte solution. Okay, anode is a metal that easily gives up electrons like iron. Cathode is something that easily takes electrons like the oxygen. And electrolyte solution is a liquid that facilitates the quick movement of electrons from anode to cathode. So corrosion is the deterioration of materials by chemical interaction with their environment. The term corrosion is sometimes also applied to the degradation of plastics, concrete, and wood, but generally it refers to metals. It involves surface of the object changing from an element to a compound. When metal atoms are exposed to an environment containing water molecules, they can give up electrons, oxidation, becoming themselves positively charged ions. Okay, for example, you have a cargo of ore. Okay, ore. For example, you have boarded a bulk carrier. Corrosion happens. Deterioration of materials by interaction with their environment. There's the energy input. Okay, then the metal is affected because your ship is made of metal or steel. Then there's energy loss because of the corrosion products. Look at this anode and cathode process. Okay, there's involvement of oxygen and there's the water and paint layer is there, and your ship of course is made of iron. Therefore, the corrosion will happen. Metals are usually extracted from ores through the application of a considerable amount of energy. Certain environments offer opportunities for these metals to combine chemically with elements to form compounds and return to their lower energy levels. Rust is a special term given to corrosion of iron, or Fe, in the periodic table of elements. Metals lose useful properties including malleability, ductility, and electrical conductivity due to corrosion. Looking on the picture, you will see the process of painting. No? So that means you have to paint. There should be a surface preparation and then painting. Galvanizing is covering metal with a layer of zinc, the most durable metal plating. Painting is covering metal with paint, on the other hand. Tin plating is a coating of metallic tin on base metals such as iron and copper for their protection. Tin plating ang tawag doon. Then we also have electroplating. It's the process of plating a metal onto the other by hydrolysis, mostly to prevent corrosion of metal. Okay? So we have galvanizing, painting, tin plating, and then electroplating. For ship corrosion, we have aqueous corrosion. Corrosion by seawater, known as aqueous corrosion, and it's an electrochemical process where ions are exchanged between metals on the ship's hull and propulsion and maneuvering system. Combating seawater corrosion can be done in many ways, including protection by coatings, changing the potential of metal to a point where corrosion ceases by impressed voltage or coupling to a sacrificial anode. Okay, the term sacrificial anode, ito yung ini-install sa mga ballast tanks sa barko. Okay, para instead na yung barko mo yung kalawangin, it will be the sacrificial anode. And then you have to replace the anode once it is worn out. Use of corrosion inhibitors and avoiding materials that corrode easily where possible. You can also use galvanic corrosion. It's the choice of materials cause, prevent, or corrosion where different metals are in contact with each other. Galvanic corrosion can take place. This can extend beyond the different structures to include bolts and fixings and or even welds. Okay, it happens when there are two different materials. This one is bronze, for example, or brass, and the other one is the nut. Looking on the drawing, this one is the bolt. Okay, it's made of brass. This one is a nut made of mild steel. Okay, then galvanic corrosion occurs. Now for ship corrosion, next one is the microbial corrosion. Microbial corrosion of fuel tanks is an issue that has only come to light since the turn of the century. It is a problem in some cases where fuel tanks contain quantities of water and certain organisms are also present. The microbes alive in the fuel or water interface and draw their nutrients from the fuel. Okay, so microbial corrosion. For ship protection against corrosion, we have this what we call the corrosion inhibitors. Okay, corrosion inhibitors or anti-corrosive is a chemical compound that when added to a liquid or gas decreases the corrosion rate of material. Typically a metal added to bilges and other places where seawater collects will provide protection inside the ship and on superstructure. Inhibitors coat the surface and prevent corrosion. So those are what you call corrosion inhibitors. Next, for the protection against corrosion, it's the cathodic protection system. In simplest form, it's cathode protection or sacrificial anodes, usually made from zinc. Okay, are attached to the hull and the surrounding seawater, behaves as an electrolyte, allowing a natural electrochemical reaction to take place. The anodes gradually wear away and become spent, but in doing so, protect the main hull or other sea from corroding. Okay, so ito yung sinabi ko na ini-install. Those are the things, no? Cathodic protection. Okay, nauubos yan. Yan yung kinakalawang instead of your hull. Next protection against corrosion is the ICCP or the Impressed Current Cathodic Protection. It's an improved version of cathodic protection known as Impressed Current Cathodic Protection, which uses an arrangement of hull-mounted anodes and reference cells connected to a control panel, meaning there's a technology involved, okay? It includes an arrangement of hull-mounted anodes and reference cells connected to a control panel. Looking on the picture, these are the typical system components. We have the rudder stock bonding, the shaft earthing device, linear strike anodes, PSU or power supply unit, and circular anodes, and then also reference cells. Okay, it's a revised cathodic protection. Okay, with a technology. Coatings must be effective if they are to prevent corrosion. Performance can be affected by poor preparation or application, mechanical damage caused by any of several means, and also the action of marine organisms. In ballast tanks in particular, sulfate-reducing bacteria left undisturbed in marine silt or mud deposits will produce concentrations of hydrogen sulfide that are particularly aggressive to steel. Some damages, such as those caused by the action of anchors and anchor chains against the hull and above waterline mechanical damage caused by contact with objects at sea, quays, and tug operations are usually visible and should be repaired at the earliest opportunity. This is necessary because under the right conditions, corrosion can take hold and spread rapidly. Okay, ngayon lang mag-join si Cedric. Okay, so that is all for the protection against corrosion. We have coatings, cathodic protection, the ICCP, and etc.